Part of the magnetic field around a long straight conductor is shown in this diagram here. The shape of the magnetic field lines in this situation is completely different from that of electric field lines in the analogous electrical situation. Electric field lines radiate outward from the charge that are their sources, or inward from negative charges. But by contrast, magnetic field lines encircle the current that acts as their source. They don't have a start or end point like electric field lines do, otherwise we would have magnetic monopoles which do not exist. Straight conductor, and again you can stick your thumb in the direction of the current and then your fingers then will point in the direction of the magnetic field, which I've shown here, okay, direction of the magnetic field. Thus, if we construct an imaginary closed surface in a magnetic field, no field line can start or end inside this surface. The number of lines emerging from the surface must equal the number entering it. So you can see, because these are continuous lines, doesn't matter what surface we construct around it, the amount of magnetic field that enters one side will be the same as the amount that leaves. We have shown that the number of lines crossing a surface is proportional to the flux. Whenever you hear me say flux, just think of this symbol from now on. Hence, in a magnetic field, the flux across any closed surface is zero. Remember, this is the closed surface integral of the perpendicular component of the magnetic field across the area, yeah? So if it's a sphere, you're talking about all the perpendicular components around the sphere, if the sphere is a closed surface. So what we're saying is whatever magnetic field enters the surface will be the same that leaves it. So that's why you've got the zero. We're not saying it's zero because there's nothing going on. You know, there could be a lot of flux movement. We're saying it's zero because the amount going in equals the amount going out, so they add to zero. Now this equation here should be compared with Gauss's law for electrostatic fields, in which the surface integral of E over a closed surface equals 1 over epsilon naught times the enclosed charge. This equation is an alternative statement of the fact that there is no such thing as magnetic charge to act as a source of magnetic field. The sources of magnetic field are moving electric charges, as I've just described.